This is lesson 41, pages 98, 99, write polynomial functions. Now, polynomial function can be, it can even be linear. We're talking about their functions, so we're talking about f of x in terms of what they would graph. And these are going backwards. I'm going to actually give you the zeros, the places where it crosses the x-axis, and then you're going to give me the polynomial of least degree. Now, I'll explain that here in just a minute. Let me see if I've got room to write this. The total number of zeros, let's see how I need to say that. The total number of zeros of a function is the least degree of the function. Now, the reason I say least degree is because the first one we want to do, fairly simple, number one, is I'm going to tell you I'm thinking of a polynomial function whose zeros are 3/2 and -2. You've actually done this. We've actually done this. And we want to know, and now what happens is when I say of the least degree, that means 2 zeros would be quadratic. The degree is 2. Now, if I had just said the degree of the function, what if there were 2 -2's? Then it would have been cubic. So the number you see is going to be the number of the degree of the polynomial I want. And I do not want a GCF in front of it other than a given 1. I think that'll make sense too. So we've got f of x, because we're not necessarily changing the shape of it when we're graphing it. So we're going to put our factors of 2x minus 3 and x plus 2. Remembering, if you know the solutions are the zeros when you graph it. And then we're going to take the understood 1 out front. And so when we FOIL that out, we'll get f of x is equal to, and I'm going to do some of the arithmetic in my head as I go through it. I'll talk you through it. 2x times x is 2x squared. And then 2x times the 2 is the plus 4x. And then you've got the minus 3x in the middle, which will give you plus 1x, and then the minus 6. So what we're saying is, if you graph this, you have degree 2, and you have these two are the places where it would cross the x-axis. It's a parabola. It opens up basic information. Now let's go up a degree, and let's do number 2. Now, some things are going to happen when we get into irrational and into imaginary. But right now we're just doing on page, what is this? This is page 98. We're just doing a basic integer, everything's nice. So we're going to do 3 zeros and 5, 1, and -4. So I want a polynomial of third degree. I want a cubic polynomial function that has these 3 solutions, zeros, where it crosses the x-axis. So f of x is equal to x minus 5, x minus 1, and x plus 4. Now, you're going to have to FOIL. I would pick 2 to FOIL first, and I just happened to, when I did it, I picked these 2 first. You can take any 2 you want to. I'd either take the first 2 or the last 2. It's just easier to do it. So I've got equals. So when I FOIL these 2, I have x squared minus 5x minus 1x is minus 6x, and then plus 5. Now I'm going to have to distribute the x plus 4. I can't call it FOILing because I'm multiplying. I'm not multiplying 2 by 2. I'm multiplying 3 by 2. So I'm going to have 6 terms. Now, to me, it's easier to take the little one, the binomial, and distribute the x all the way across, and then distribute the 4. You can distribute the x squared, the -6x, and the 5. Either way you go about it, you're going to get the same 6 terms. They'll just be in different order. but commutative property says that they're the same. I just always like to take my binomial. So I'm going to take the x and distribute it to all three. So I'll have x cubed minus 6x squared plus 5x. And then I'll take the 4 and distribute it, and I'll get plus 4x squared minus 24x plus 20. Now, putting my like terms together, and I'm going to put f of x out here again. You don't necessarily have to. It just looks better to me. I'm going to put my x cubed together, and I'm going to find my x squared terms, which is negative 6x squared and positive 4x squared. And I like to lightly mark those out because I know I've counted them. And then I have a 5x and a negative 24x, which is a negative 19x, and the plus 20. Now, if you have time, and I'm not going to necessarily do it because time is especially major on quizzes and things like that, but you could technically go to your calculator on y equals, and you could actually type in the top one, x minus 5 times x minus 1 times x plus 4, like in the first one. And you could type this in the second one. And when you graph them, especially if you're on color, you'll see the first one graph blue. And then the second one, if you've done your algebra right, should graph right on top of it. To me, that's just a time factor I don't have time to do, but it is something that you can do. We're not going to go above, let's see, I think we're not going above 4 zeros. Let's see what's going to happen. Number 3. We're going to do zeros. Better not get ahead of myself. We're going to do negative 2, positive 2, positive 5, and negative 5. So my factors are x plus 2, x minus 2, x minus 5, and x plus 5. Now, it will definitely be easier to FOIL each of those because you should know that those are a difference of two squares. And so when I FOIL this one, I'll have x squared, and then my plus 2x minus 2x subtracts out, add outs, and then I get minus 4. And then this one is a difference of two squares. I get x squared minus 5x plus 5x, and then minus 25, which makes it so nice. So technically, even though it's not just x and x, I can still treat it like FOILing, but I will put all the 4 terms because it's a little bit different. X squared times x squared is x to the 4th. X squared times negative 25. My outside is minus 25x squared minus 4x squared, and then plus 100. So I get, and I'm going to put f of x equals x to the 4th minus 29x squared plus 100. Okay, let's do one more with nice rational solutions. Let's do zeros are 3, negative 3, 2, and 0. So I've got degree 4 we had here. I didn't write that up here. Degree 3. This is degree 4. So I should have x to the 4th when I get through with it. And so I have f of x is equal to x minus 3 times x plus 3 times x minus 2. And I'm going to literally write it x minus 0. Now, I technically would not do that normally, but I'm going to leave it like that because I've got to do some cleanup anyway. So I've got these two. I'm definitely going to multiply together first because they're, again, a difference of two squares. Let me see if I can straighten that up. And I have x squared plus 3x minus 9. And then I have x minus 2. But x minus 0 is just x. Now, a lot of times you'll see that x out front, but it's commutative for multiplication. You can do it any whichever way you want to. I'm going to FOIL these two. And I think I may go ahead and bring that one out front. We're just used to distributing more from the front. Now, this one's going to be a little messy because I've got x squared and x. So when I FOIL it out, I won't have like terms. I'm going to have x cubed, x squared times x. Then I'm going to have minus 2x squared. Then I'm going to have minus 9x. And then I'm going to have plus 18. Now, you could have left your times x back here or out front. I'm going to distribute that. And I have x to the 4th minus 2x cubed minus 9x squared plus 18x, f of x. And this one actually will cross the x-axis at 3 and -3, and at 2, and at 0.